Go now?
Yeah.
Yeah? Hey. Hello. My name is Sebastian. I'm a PhD student with Pierre. I've originally trained as a psychologist, but then I've slowly graduated or moved more in the direction of neuroscience and a bit of computational neuroscience. What I'm going to talk to you about today is how you can use open data sets in your hackathon projects. So I'm currently finishing up my PhD. That means I'm probably not super available, but if you have questions, you can send me Slack messages. And apart from datasets, something that I have a bit of experience with is using Python for neuroimaging analysis and visualization. So if you find yourself in a pinch and there's nobody to ask, you can probably also send me a message. All right. So the purpose of this talk is to give you a rough idea of the datasets that are out there and how you can access them. But before we start, I would like to ask you if you want to follow along or just in general have an easier time finding access. There are two tools that you'll probably end up using to access most of the openly available datasets that are out there. So one is called CyberDuck. That's a graphical interface where you can click and do stuff with a mouse. But that only works on Windows or Mac. And the Linux variant of this is a command line interface called Aws Cli. And the reason it's called that is because the data that you're accessing is on the Amazon Web Services. That's where most of the openly available data sets are stored. And I'm not going to go into too much detail. If you have some questions about that, we can go over that in the end. But just keep in mind, most of the data out there is somewhere in an Amazon S3 bucket, and that's how you get at it. And if you want to install those in the background for the command line version, that's a Python package. So you either go with pip install, or if you know and use virtual environments, you might want to install that in a virtual environment. Okay, so just so we're all on the same page and I don't want to waste anybody's time, what this talk is about, and if this might be for you, is if you are currently asking yourself, how do you figure out if something is a good data set for you, and especially in the context of this hackathon? How do you find one? How do you get it? And then just a very little bit, how do you use it? I'm not going to go into too much detail on that. But these first 3 points I'm really more focusing on. So how do you choose a good data set? Well, three main questions that you have to ask yourself. How easy is it to get access, right? Like, how quickly can you get your hands on the data? What's the state of the preprocessing? I'm going to talk to you about that in a second. And then the last question is, how useful is it to the thing that you're trying to solve right now, right? So you might have already figured out what your project is, or you might just be thinking about that. And it's important to keep in mind that data sets may have some but not all of the things that you're looking for, and it's really a good idea to check that in the beginning, because you can also spend a week and then figure out that you're missing some critical aspect of it. All right, so what is ease of access? Most of the data that's openly available lives somewhere on the spectrum, right? So I've kind of ordered it from hard to easy access, but really what it means is more how long it takes you to get that data. So on the left side, you have something like a data usage agreement that you would have to sign in order to get access to the data. So don't use this kind of data. That's usually takes a long time for you to fill this out and get it approved, right? That's not what you want to do in the context of a hackathon. Something in the middle is data that is stored and accessible through a database. And the reason I'm putting it there is because personally, I find it's usually really difficult to figure out how those databases work, how you can find the data you're interested in, how you get the download, and this typically takes quite a bit of time to figure out. And so really the easier data is something that might make sense in a hackathon context, is where you can just download it, either through the AWS bucket, or I'm going to show you another method to do that later, or where you've already downloaded, right? So those should be the type of data sets that you're interested in. And if something is only available through a database, I would say maybe keep looking. The second question is, how raw is your data set, right? And that also is kind of like a range of possible stages of your data. You can think of this kind of as the life cycle of a data set. It begins with the recording of your data, and that typically is in some scanner-based format. Usually, depending on who acquired the data, the organization might be quite particular, and you probably don't want to touch this stuff because it takes a long time to organize it in a way to be useful. Somewhere further down the line, you might have data that is still raw, but it's already organized, ideally in a format that is standardized. So some of the tools that you might have heard about last week would already know how to use it. The most important thing there would be bits. I'm not sure if you already heard about bits, but that's a data organization standard that's very well supported. But you still have to pre-process that data, right? So you might get your hands on pre-processed data, and in fact, most of the data I'm talking to you about today is available as pre-processed data. The important thing to keep in mind there is that data might be minimally pre-processed or pre-processed, so you can just throw it into some kind of stats algorithm. What minimally pre-processed means is that in an imaging context, some of the artifacts and pre-processing steps have been done, but you still have a choice on how you want to conduct the specific statistical regression and correction for nuisance covariates and all of these things. So if you are starting from scratch and really don't feel comfortable dealing with these things, maybe you should go for something that is fully pre-processed and trust the people who've done that and just get on with your life. And then at the last step is something, I mean, derivatives is kind of a confusing term here. You have to be careful. Sometimes derivatives are also pre-processed outcomes. But the general idea is somebody has done an analysis and you're looking at the outcome of this, right? So statistical maps or somebody's already computed a connectome, something like that. And those data are also available out there. I'm not going to talk too much about them, but you can find them as well. And in this case, just go off of what somebody else has done. Right, and again, you probably want to find yourself somewhere on the right side of things where it's easier, but obviously you have less control over what has happened. Now, this is an important question. I think somewhere I've pointed out that I'm taking quite liberally of Chris Kogolevsky's slide here, who was just given this talk like a week ago in the Neurohack week. If you now found your data set, you might want to ask yourself, well, how do I know if this is a good data set, right? I mean, it looks like it has everything. So one of the things you might want to ask yourself is, well, is there a publication, right? A lot of good large data sets have actually been published as a paper that you can read and cite, and where a lot of the acquisition details are listed, so that would be a good sign. You might also see that somebody has already worked with this data, which is another good sign, right? At least these people trusted it. And because you're at the hackathon and you can just walk to other people and talk to them, which is generally a good idea, you could just ask, right? Is this a good data set? Have you heard about this? Are there any issues with it? The second part is a bit more tricky because it means that you should already think a little bit about what your project is, but it's really important because what this means is you might find a data set that has fantastic imaging quality, right? So huge sample, perfect quality of the data, but then you figure out the thing that you want to look at the behavioral battery of tests or something isn't actually available, right? So now you've spent all this time preprocessing the data, and at the end of the week you figure out I can't actually run my analysis because that data isn't there. Or it might look like it's there, but then half of the cases in your data set have missing data, right? So that is another thing that I would encourage you, once you're narrowing down on something, to look at before you really dive into the analysis, because those are the things where you will lose time in the end, right? So just spend another hour, have somebody sit down with you and check if the data you're interested in is actually available. And then lastly, data cost. So what that means is kind of a mix of the previous two slides. Is it really difficult for you to get that data? You probably don't want to sit here until Wednesday and download it. Also, excuse me, if the data isn't preprocessed, just think about, would you be able to preprocess it? Would you like to wait for somebody to do that for you? So you probably want to keep that in mind as well. Some data sets might look very attractive. They might just be out of scope for the time that you have available. All right, so now you've got some guidelines on how to choose data. Well, where do you find data? I think for the purpose of the hackathon, the two best sources for you are probably either the OpenEuro website or the FCP Indy website. So the FCP Indy website, that's kind of where the data sharing has started. FCP is came out of, I think, the 1000 functional connectome projects. I mean, Claire probably knows a lot about these things. And those data sets have been shared since a long time. There are many smaller and larger data sets that you could look at. OpenEuro is a little bit more recent, and the idea is the same. It's large data sets that have been shared with documentation. Both of those are, as I said in the beginning, available through the Amazon S3 bucket system. So what would this look like if you... wait, now I have to find my mouse. Whoops. So let's say you go to the FCP website, right? That's what you're going to be greeted with, and so you have the 1000 functional connections project. That's a relatively old sample. Then you have the prospective and retrospective data sets, where if you click on those, you just see what is already available with some description. And if you click on this, you get some details. But what I really want to show you is this here. So Aws S3 Resources, this is a website. Well, they're telling you essentially what I've already told you. You need CyberDuck to get your hands on the data. But if you click on this, you see a number of data sets that are available in this way, right? And already you're getting some kind of idea of what might be in these data sets. So you have autism here, you have addiction, ADHD. And if you click on them, you get a more detailed website that has more information on how the data has been acquired, what the criteria were, and who are the lead authors on this data set, right? So you could scroll through these and find something that interests you. And an important column to see here on the right is whether those data sets have been pre-processed for you, so whether pre-processed data is available. And most of them actually have, which is really nice. Now, let's say you want to use one of those. Then what you're interested in is this line here. So what this line is a path to an Amazon storage. And you can, I forgot to actually start my Windows machine. Whoops, no, this is incorrect. Oops. And what you can do with that, going to show you quickly. Right, actually, just a second. I'm going to change my screen so we all see the same thing here. Okay. Sorry about that. Okay. So let's say you were on a Windows machine and you wanted to access the dataset that I have just shown you. Then you would go copy this line here, go to your Amazon interface, like your little CyberDuck thing, and click on anonymous login, because all of these datasets don't require you to actually give any user credentials, and then you just copy the path down there, right? So I don't know if anyone of you has already downloaded the software, but essentially what you're going to see there is now you're in the FCP Indie Abide project, and you can see that they have all kinds of things for you to download. There's phenotypic data, there's raw data organized as bids, and there are some derivatives. So, for example, this has been pre-processed with CPAC, this has been pre-processed with NEAC. And this is really a nice way for you to get access to this data, because all you need to do, which you shouldn't do right now on the Wi-Fi, but you just need to right-click and then download, right? And so that's the nice thing about the graphical user interface. If you were on a Linux machine, what you would do, oops, so you would just do something like ls oops, and then you just copy the path in there. So what I've just done is I've recreated essentially the same command just from a command line, and so AWS is this little command line program that I've told you about before. S3 is just what Amazon calls these data storage units, and ls means list. And so there's no sign request. It's the same thing as clicking anonymous. And if I hit enter, it'll probably take a second, and then I will see the same stuff, right? So here are derivatives, all of these things that you've just seen. And then if you were on the command line, rather than clicking download, you would just you would do sync, right? But all of these things are documented on the web, and actually the AWS command line interface is very extensively documented from Amazon. So you can just Google that and see how that works. Okay, so that's the FCP Indie side of things. Now, there's also OpenEuro. So OpenEuro is organized a little bit differently. It's, oops, not signed in. You actually have a lot more data there, and some of them are relatively small. And the way that OpenEuro works is that you can search for things, right? So something you might be interested in is, I don't know if you've heard about this, but there's the Midnight Scanning Club. So that's just a bunch of people got together and then scanned themselves, and this data is available here through OpenEuro. And you now get essentially the same idea as the FCP Indie website that I showed you before. There is information here on the dataset. It's even version controlled on the side. You have an idea of who authored it, which becomes important once you actually decide to use it, because you should cite those people. And then if you decide that this is the dataset that you're interested in, you want to look at it, you click download, excuse me, but rather than actually download it, you again get the path to an AWS bucket, right? So that's why I keep telling you about this, because if you want to have access, you need at some point to interface with AWS. And this actually already gives you the download command here for the whole thing, which I've just used on the command line up there, right? So if you forget that, or you don't want to bother looking up the documentation, you just copy the whole thing, and this will then download. This will download the data onto the path that's specified here. Now, one thing that's important to keep in mind when you're working with OpenNeuro is FCP Indy has these relatively easy to remember names, right? So something's called a byte. Those are just the names that the original authors have given these data sets. On OpenNeuro, data is referenced by a dataset number, and that is not intuitive at all. It's literally just a number, right? So it's DS and then a bunch of numbers. And that's what you need to access a dataset. So if you were to do what we've just done for the FCP Indy data, whoops, here, let me just do that. Then you would just see a ton of little data sets, right? And now you have no idea what these data sets are, but lucky for you, you can go back to the website and well, I mean, here you could just go and take it out of the command, right? So it's DS000224. And then either you find that here, or you put it in the path directly. And now again, you have access to the data. You can even browse through it, and you can download it. Right, so we're doing on time. I feel like I'm quick. Maybe if you have some questions later, we can use the remaining time for that. Okay, so now maybe you don't like any of that, right? And none of those data sets appeal to you. There's also a nice GitHub repository. It's called OpenMorph.
It's like, how many data sets are on OpenNeuro and Indy?
Oh, a ton. Yeah.
A ton, as in?
I have no idea. It's many.
Hundreds, I'd say it's in hundreds.
Yeah, and that's actually a bit of a risk there. So I would say if you look at FCP Indy, you have a pretty good idea that that's a really high quality data set, right? Because somebody went through the trouble of actually pre-processing it and putting it on this website and hosting it on Amazon. OpenNeuro is a bit more hands-off in terms of who can put their data there. I mean, I can put my data there, right? That should give you an idea of the quality. So yeah, I mean, I can keep scrolling here, and the Wi-Fi can't even keep up. It's a lot of data sets. So yeah, I just want to highlight that because I think it's a really nice effort. Some of those data sets you've already seen, right? Because they're big data sets and people keep using them. But there's some that I personally didn't know, like the Australian imaging and biomarkers data set. So maybe one of those data sets interests you and gives you some inspiration for a project you want to work on. Just keep in mind, a lot of the more well-known openly accessible data sets are really large, so you might not want to look at everything in there. Okay, and what if all of this, yeah?
I have another question. What's in those data sets? Because you keep talking about them, but you haven't said what kind of data is there.
Yeah, that's a good point. So if we're talking about neuroimaging here, what is in those data sets is either the raw imaging data or the pre-processed imaging data. So if we're talking, for example, functional connectivity or resting state fMRI data sets, you would typically have an anatomical scan and a time series file, right? So if those concepts make sense to you, that just means that somebody has made an image of the brain of a person, and then they've scanned that person's brain over time to create a time series, which is a 4-dimensional image of the brain. So essentially you take pictures of the brain every couple of seconds. Now that by itself isn't very useful because you probably don't care about that person in particular because you ideally don't know who they are. So what makes the data set really useful are the metadata, right? So maybe you look at this data set and it's about autistic people. So now you can ask questions about autistic people. Are maybe autistic people different in terms of brain organization than healthy controls? Or are there some behavioral tests in there that you might be interested in and trying to relate those to structural abnormalities in the brain or some, like, that's basically what you're figuring out as I understand it right now. So that's why it's important before you decide on a data set that you really look not only at the data quality, the number of individuals, but also the metadata, right? So short answer to Pierre's question is you have imaging data and you have metadata. And the metadata is what makes data sets attractive. I mean, the data quality, you hope that is good, but the metadata is what makes it interesting for your research questions. So I've talked to you about FCP Indy, which is a great resource to find common, well-known data sets. I've talked to you about OpenNeuro, which is another great resource to find some lesser-known data sets, but well-documented data sets, and just type a search term and find what's out there. I've shown you OpenMorph, and then the last one I want to show you is NiLearn. So I'm thinking you've already heard about NiLearn last week, right? So NiLearn is this great Python package that has almost everything you would ever want in order to do neuroimaging data analysis. But one of the nice things that NiLearn also has is data grabbers. So a data grabber essentially is a little package that gets the data for you. So you don't even need to bother with AWS or wherever the data is stored. The only thing you do is you go in your little Python terminal and you type get me, for example, ADHD 200, get me 10 subjects. And it does that for you. Not only that, it already knows about the structure of the data and it knows about the metadata. So I'm gonna show you in a second how that looks like if you're doing this. So we've already gone about over the AWS side of things, which is where most data is. And then there's the NiLearn side of things, which is what I'm going to show you now. For some select data sets, including atlases and some derivatives, so not only pre-processed data that you can do analyses with, but also the outcomes of analyses that other people have done. Right, so the Amazon S3 example I've already shown you. So I'm just, that's how you do it. You pick a data set, you go and log into the bucket either through the command line or your CyberDuck, and then you download the data. I've already shown you how to do that. And if you want to do it with NiLearn, you do almost the same thing. You find a data set that you're interested in, and then you ask NiLearn to get it. Right? So how might you do that? Well, if we open the NiLearn documentation, everything is very well documented in NiLearn, which is another great thing. They have this list of their currently implemented automatic data fetchers, right? And so here you have all these data sets. It's not particularly informative. You might probably want to either Google the data set or, well, there's something else you can do, but let's just say you might not know already what those data sets are. But let's say you're interested in ADHD, and that's easy to spot. There's an ADHD resting state data set. So you click on Fetch ADHD. And now you're looking at the documentation for this specific function, right? And you can see it's a really easy function because it only takes, well, I can't count, 5 arguments. And most of them are actually not that interesting. So the first one is how many subjects do you want to download, right? So if you look in the documentation, what does it say? You can download up to 40 subjects. Okay. And then the data dir is that allows you to tell NiLearn where to dump that data on your computer if you want to bother with that. You don't have to. NiLearn has a default download directory. You can just leave it at that. And then the URL you don't need to bother with. Resume and verbose. Not that interesting. So it's pretty simple. You just tell NiLearn to get that data and how many. So let's see. I'm just going to show you quickly how to do that. Okay. So I'm not sure if you've seen Jupyter notebooks before, right? But yeah, great tool for data exploration. Only recommend them. So we don't need to bother with this. I'm just importing a number of packages that help me work with that data. The important part is that I imported nylearn here, right? So you might have seen this kind of syntax where you basically tell your Python interpreter that now you want to also access functions from nylearn, and that's how you do that with an import statement. And now I have nylearn imported, and I can say nylearn datasets fetch ADHD. If for some reason I forget how this function works, I can do shift tab, and it tells me, right? So n subjects 30, blah 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 blah. I can do all of these things, but I only want one subject because the Wi-Fi is slow, and well, actually lucky for me, I've already downloaded it. But now, let me see. Can I close all this? All right, it's you already see what the output is going to be because I ran this before. But essentially, what you get from this is nylearn downloads the data somewhere in your computer, but the data object that this function creates is really interesting in itself. So that's a dictionary. Some of you may know Python object dictionary. What it means is there are names in that dictionary that denote fields, and those fields hold information. So you can look at that with keys. It doesn't really matter. There are 4 fields in this data set, and we can look at all of them, right? And so maybe you still don't really know what this data set is, but luckily the description field is a very detailed, well, somewhat detailed text that explains what you can find in there, who made it, and what the other parts of this data set are. And then you can look at func. Func tells you where nylearn downloaded the data set. And then you're already there, right? You can just say, load this data set and view it. You know, that's how easy this is. Now you're looking at the first time point of a time series image that you've just downloaded through nylearn. And obviously, if you want to do some additional analysis with this, then you need to figure out how to do that. But getting the data on your machine and accessing it, super simple. In fact, if I had 2 subjects, which I'm not going to run here, the field func here, there would be another line for the second data set. So that would allow me to algorithmically iterate over these individuals and load them one by one and do all kinds of fancy things. And you also have confounds from the preprocessing that you might want to look at for your nuisance correction strategies. Okay. So nylearn is another great way of accessing data. And I've just shown you how all of these things work. Great. So I'm already through with my slides almost. The last part is really just me giving you some pointers as to how to work with the data from experience. But if you have some questions after this, we have about 20 minutes left after that. Talk about questions. Yeah.
I have lots of questions for you. I'm Sebastian. The only one nagging you, but you should get on it. He doesn't mind.
As long as I'm here, I don't.
Is there what you describe as MRI data, right? When you were saying imaging.
Yeah, that's MRI data. Yeah.
Are there some more like EEG, MEG resources listed?
So that's a bit beyond my knowledge, I'm sure. Right. So I know, for example, that if you're interested in genetics data, there are some interesting data sets out there. I don't know about EEG. I would assume that. I mean, OpenNeuro definitely has diffusion data. I'm thinking they would also have EEG, but I don't know that. The easiest way to find out would probably be to just Google it. Sorry. Oh, actually, yeah. I'm going to tell you that in a second. You can actually just Google it, which is also nice.
We can always follow up to Slack or whatever if you know, great.
Look, there's a data set called EEG.
Data.
I mean, there you go. Now you just need to know how to analyze EEG data.
And haven't they created like a bits format for EEG?
Yeah.
Yes. Right. There are. Oh yeah, I think there is EEG.
Sylvain Bayet, Cyril Pernel, a bunch of other people have created a bit extension for EEG.
I mean, there are lots of bits extensions now.
And I think there's Omega, which is associated at McGill.
Yeah.
Yeah.
There's a lot of data set. Yeah, lots of subjects in there.
But that's MEG, right?
Yeah.
Okay.
Some RC state, some task technique as well.
Cool. Yeah, I don't personally know about those, but cool. Other questions? Okay. Just my 3 points about how to work with the data. First one is getting data is a lot of work. You should respect it. Sounds simple, but some of those data you can get without signing the data usage agreement. Don't do that. It's not legal. It's also not good. Some of those data include patient information. Those people have agreed to be part of science, so you should respect them as well. Don't share or insecurely store any personally identifiable information. And then lastly, once you've used that data, cite it, right? Because people who share data, that's part of their job, and part of how we evaluate it is by these metrics. So you should acknowledge their work. Yeah. Second thing is more for you. Document everything you do, even though it's just a week. I know people are forgetful, and just trust me from experience, it's a great idea to write down how you get the data, how you select the sample, and anything you've done that isn't just click download. And even if it's just click download, just remember how you click download. That might help you a lot next week or further down the road. And then in a similar fashion, organize your project. So that's a bit more of a personal thing. You don't need to do that. One thing that is really useful, and you've probably heard about that last week as well, is version control for anything that is code-based. If your analyses and even your data acquisition is code-based, that is good for you because it means that you can reproduce it easily and quickly, right? So if at some point during this hackathon or during your career you figure out that you've done a small mistake, then if this entire process has been scripted, it might be much easier for you to fix it together with the documentation. And there are some good pointers on how to organize a data science project. For example, this cookie cutter data science is a good resource that I can recommend. Don't do everything they do if you don't want to. Just take some inspiration, and the more structure, the more documentation you can have in your data, the better for you. Okay. So some things I haven't talked about that you might also want to know about if you're interested in looking at data. There is Zenodo, which is a European platform that the goal of Zenodo is to host all the data for a publication that makes it reproducible. So whether that's the outcomes, the raw data, the software, which means that you can go on Zenodo, scroll through the papers, and maybe you find something that really interests you, and then you can see how you get access to that data set. Right, so that's a nice resource. Also, it's hosted in the CERN, which is cool. Then there is Figshare, which is a very similar idea. Also a repository for data. Something that I didn't say, by the way, these data sets have digital object identifiers, or DOI. You might have seen them. Most papers have that as well. And that's a really nice way to keep track of what you're talking about and reference the data set. So Figshare is almost the same idea, just has a commercial side. And then there is, in fact, now a Google dataset search, which you might want to try out. And it just works as you imagine. You click on it and you type in things, and it shows you data sets. And then lastly, what I haven't talked about much during the presentation is how you get to data that's already analyzed in a way, right? So NeuroVault is that's exactly the idea of NeuroVault. If you run an analysis, and let's say you do some kind of group contrast and you find differences somewhere in the brain or some spatial map, those statistical maps you can upload to NeuroVault, and then other people can use them and look at them and do further analysis on those. Neurosynth is a similar idea that's automatically parses papers for the peak coordinate values in activation studies, right? And then you can inverse search those maps based on some keyword that you're interested in. So if you search pain, you get like some distribution of peak activation maps in the brain that were found in studies that have pain in it as a keyword. And lastly, I mean, you're here and there are many people around you who can help you. Neurostars is a nice forum on the web where you can also get a lot of support relatively quickly. If you haven't heard about it yet, I recommend you make an account there. And if you ask a question, typically somebody who is knowledgeable replies to you relatively quickly. Okay, that's it on datasets. Good luck. And if you have questions, let me know.
Okay. I guess you're all good. Do you already know what data you're going to be using? Is anybody still like sort of undecided about like data sources? All right. So you now have lots of pointers to dig in. I see Antoine has posted a repo of OpenEEG data on the Slack. So there's so many data, so little time. So I have to, make a choice and dive in at some point. Good luck with that, and we got the room up there until 5. And happy hacking again. Thanks, Sebastian.
Sure.